Okay, everybody, this is 9.1, number 21. Everybody knows this is a fun problem, and everybody's going to be able to do this just fine. I'm laughing because Mrs. Fontana has been listening to me record stuff all day and says that I say everybody too much. That can't possibly be true. All right, here we go. Go Bears. Apparently, I also clap and say go Bears a lot. So this problem looks like this, everybody. It is the square root of 1 plus x squared times y prime, or dy dx if you want to change it to that, equals the product of x times y. I'm hoping by now we can mentally be aware that that y prime is a dy dx, that the dx is going to get multiplied over here, and we want all the y's on this side. So we're going to divide by that y right there to bring it left, and also divide by this square root here to bring it right. And that is going to get us, voila, 1 over y times dy is equal to, now this x stays put there in our numerator. This whole factor here we divide out to become our denominator times dx. Mrs. Fontana, please don't cough. You're interrupting my video. All right. All right. So now we've got our variables completely separated here, which, as we know, is kind of a big deal. And we're ready to go ahead and we're going to try to integrate both sides of this equation. So one here on the left and one here on the right. The left side, as we look at it right now, isn't really all that scary. That's going to be a pretty simple natural log of the absolute value of y. But the right side is quite a bit more complicated. We see two distinct parts to the integrand, and given that we've got a simple quadratic function for the radicand here and a linear function here, I'm thinking that u substitution is probably the way to go. So we're going to let u equal the radicand, the 1 minus x squared. The derivative of u then becomes a negative 2x dx, and except for the negative 2, that's exactly what we wanted for our leftovers. So we'll divide that negative 2 out and get a negative 1/2 du is equal to x dx, and we should be able to make a u substitution now. And so, back to where we were a second ago, the integral of the 1 over y dy from the left side is now going to equal, all right, let's take a look at what we've got right here. So the primary substitution came from the denominator. That is now the square root of u. The x dx that were our leftovers right here now get replaced by a negative 1/2 du. There's the du, and the negative 1/2 I rather sloppily put in front of the integral, but now I think we're in pretty decent shape to go ahead and evaluate this thing. So on the left side, the integral of the 1 over y dy is going to get us a natural log of the absolute value of y. On the right-hand side, the negative 1/2 just goes along for the ride. And thinking of this as a u to the negative 1/2 power, we would integrate that by making the negative 1/2 a 1/2 and dividing by that, which is to multiply by 2, and a plus c at the end of all that. Okay, trying to clean up this right side just a little bit. We've got the natural log of the absolute value of y equaling, well, the 1/2 and the 2 cancel. The negative stays, and instead of a u to the 1/2, I made that a square root and went back to the original substitution right here of a 1 minus x squared and of course a plus c. Now, this was just a differential equation, not an initial value problem, so we are not going to be solving for c here, but we've got a little bit of work left to do here to get y by itself. Now, this is an example of what I told you guys you'd probably get the hang of. We're going to do two things at once. To undo that natural log, we're going to exponentiate both sides of the equation, remembering that all of this, the entire right side, needs to become the exponent on our e. And at the same time, to get rid of the absolute value, we're going to put a plus or minus in front of that e. So that right there, everybody, is killing two birds with one stone. Y is plus or minus e, and then this entire binomial here becomes our exponent. Now again, I wouldn't really mind if you guys stopped at that point right there and said that this was your final answer. However, the book and the AP graders usually tend to go a little step further. So they took advantage of the fact that a monomial raised to a binomial power can be split up into a product. So it's plus or minus e to the negative square root of 1 minus x squared times e to the c. And reasoning here that e, which is a constant, to another constant power is just going to be a constant in and of itself. They then make this usually a capital C or sometimes a K and bring it out in front as a coefficient of the e. And since this c right here is an arbitrary constant whose value is not being declared, we don't really need the plus or minus in front of it. It's understood that that c right there can be either positive or negative, and this right here then, as I'm looking at it, is the answer that the book has for number 21. Capital C times e to the negative square root of 1 minus x squared. See, Mrs. Fontana, I didn't say everybody even once.